Let's look at the graph of this secant function. We define the secant function as the reciprocal of the cosine. Like the tangent before it, well, we're after it, depending if you watched that one or not yet. The secant is going to be undefined, where the cosine is 0. Can't have 0 in the denominator, so the secant is going to be undefined, where the cosine is 0. And since the numerator is never 0, it's 1, that means the secant function is going to have asymptotes everywhere that the cosine function is 0. That happens at odd number multiples of pi over 2. 1 pi over 2, 3 pi over 2, 5 pi over 2, 127 pi over 2, negative 9 pi over 2. Any odd number of multiple of pi over 2, we're going to get a vertical asymptote. So let's see. There's pi over 2. That'll be pi. Watch out the spacing here. There's 3 pi over 2. We'll come back this way and do negative pi over 2. And every odd number multiple of pi over 2 going out both directions forever. The secant is the reciprocal of the cosine, so it could be useful to draw in the cosine function here. It's not part of the secant graph, but it can be convenient to sort of be able to see it. Cosine bottoms out at negative 1. So there's the cosine function. The secant is the reciprocal of the cosine. So at 0, cosine of 0 is 1. 1 over 1 is 1. So my secant function is going to have a point right there. The cosine of pi is negative 1. 1 over negative 1 is negative 1. So I get a point on my secant function. These vertical asymptotes, my function is going to go up along those vertical asymptotes. Over here, this is quadrant 1 and quadrant 4. The cosine values are positive. As the cosine value gets closer and closer to 0, the secant value, 1 over something that's getting smaller and smaller and smaller, is getting bigger and bigger and bigger. And so that'll go up next to the asymptote like we know it should. That's what asymptotes do. And it'll do that on both sides. Over here, this is quadrants 2 and 3, where the cosine values are negative. So same idea, but we're going negative instead of positive. There's my secant graph. This is one period of the secant graph. The period of the secant function is 2 pi. If I start looking at negative pi over 2, I get to the next asymptote, but I haven't started over yet. These values are negative and not positive, so they're definitely not the same. When I come over here, that's when I start over again. So the period is 2 pi, from minus pi over 2 to plus 3 pi over 2 is one period. The domain of the secant function, everything except where the asymptotes are. So all real numbers except where the asymptotes are. The range, we're going to work a little bit for the range here. Between y equals 1 and y equals negative 1, there is nothing. This is the cosine function, but it's not part of the secant function. There's not, we have a black hole here between negative 1 and 1. Going downward, I can get any negative value I want. That's an asymptote. But I can go up only to y equals negative 1, including negative 1. And then we have to jump over the black hole, and we'll start up again at positive 1 and continue with that asymptote. We can go up as far as we care to. So we have to say the range in two parts. There's our graph of the secant function. And in order to get a nice picture, we'll look at the Desmos version. And there it is. Y equals secant x.